All right. Hello, everybody. I hope that you're all doing okay. Thank you for your patience on Monday. I hope that I was able to get a message to you before you got on the bus to get here if you were coming here on the bus on Monday. I'm doing a lot better than I was. Still pretty tired, but doing a lot better. What I want to talk about today is I want to keep working on this input validation stuff. And specifically what we're focusing on is for the purpose of instance creation. What I want to do today is spend a little bit of time reviewing what we were working on last week, because it's been a little while since we've done that. And then what I want to move on to do after that is to start thinking about, now that we've identified that there is a problem with this thing, the state that we're in right now is that we're just throwing exception, and exception itself is kind of a bad way to communicate exactly what has gone wrong with the validation process. And so I want to spend some time thinking about how can we better communicate between different layers of responsibility. So this is at the development perspective. I want to be able to communicate to you folks as devs what happened. And then after that, I want you folks as devs to be able to communicate meaningfully to the user, the person that's using our software, what went wrong based on the exception that you're catching, and then how to handle that basically. So what does this person need to change about what they've entered to be able to actually enter correct input? How can they provide correct input to us after that? So what I want to be able to do, what I want you to be able to do by the end of today's lecture is I want you to continue to be able to implement input validation and error handling for an application. I want you to continue to be able to use exceptions in an application to communicate errors. We'll just expand on what we've got from the word exception to actually having custom exception types. And then I want you to begin to be able to write error messages that clearly state a problem and the action necessary to resolve that problem. So I want you to start being able to basically say, this is what was wrong with what you entered. This is how you enter the correct thing, or this is what I'm expecting as input for you to enter here. So I want to spend some time taking a look at the validation strategy overall, the goals that we have for validation and the state that we're kind of in right now. So the goal that we have, or the goals that we have in terms of validating user input, is that I want to be able to communicate what is wrong. I want to be able to communicate it as soon as possible. So as close as possible to when you've actually entered that thing, I want to be able to communicate this issue. And then eventually I want to be able to communicate to you, how do you fix the thing that you've done? What we've got right now with the strategy that we have been building up in class is we're focusing on as soon as possible. I want to be able to communicate to the person entering the information that they've misentered some information as soon as they have pressed the enter button. That's effectively what I want to accomplish here, is as soon as possible. The strategy that we've been doing to accomplish this so far is we've been delegating construction of instances to a different class. We've been delegating construction of instances to a different class that is directly attached to our domain model class. We've been using this new kind of class, this thing that we've called a builder. This is the only one that can see that constructor. We've marked this as private so that nobody else is able to construct an instance of this class, except using this delegate that we've got, this thing that we've asked to do construction for us. And this new class, this builder, this thing that we've got, it really has one single responsibility, and its single responsibility is validating all of the values that are being provided as inputs or provided by an input mechanism here. I want to quickly take a look at this diagram. This diagram was the one that we built up when we were first initially talking about this idea of layers of responsibility. And I want to amend it slightly based on what we've got with this model. And then I want to take a look at the code that we've got for this. So the initial setup for the layers of responsibility is that we're going to have our person using our software sitting at their keyboard. They're providing input to these UI classes. And everything that's in this kind of box here is one layer of responsibility. There's going to be a collection of classes here, and each class that's in this layer of responsibility has the responsibility of getting input from the person using the software. So they're typing stuff in on the keyboard. We're using classes like scanner here, but these could also be classes that are like showing text boxes on the screen to get user input from that person using our software. We said that these classes had the responsibility to take inputs, and these are in the form of strings. This is what we're able to type in and transform them into domain model objects. When we started, this was effectively, they should call the constructor. They should get all the inputs and then call the constructor of that thing. But we're going to change this slightly. Instead of taking this input as strings and transforming it directly into domain model objects, these are going to effectively ask the delegate so I'm going to write the word builder in here, but this isn't our domain model. We're going to ask this delegate class to validate input and construct instances. So our UI layer now has the responsibility of getting input. It's still taking input as strings, but now it has the responsibility of asking our domain model class delegate to be able to validate the inputs and construct those instances so that our UI layer can then pass those domain model instances to the logic layer. The rest of it kind of proceeds at this point. Yeah.
Records, how do we have that builder pattern that we can't really make constructor private?
That's a great question. The question is, in the case of records, how do we do this builder pattern? You kind of can't. I don't think you can mark constructor as private. I know that you can redefine the constructor. I'd have to look at the documentation to see if you can actually mark it as private by redefining the constructor, but I don't know if you can. In that case, what I'd say is you should raise your record to a class and start making it a class that has a bunch of final properties as opposed to just defining it as a record.
And like, can we keep like a builder class for it, even if the constructor isn't private? That's what I was thinking. Have a builder that each channel is communicating to that record with. So don't use the constructor directly.
That's a fair question. The question is basically if we are not able to make the constructor private, if we're forced to leave it public, is it still okay to have a builder? The answer is yeah, of course, it's still okay to have a builder. The risk that you're running with that is that by not prohibiting construction using the constructor, now there's two ways to make an instance of this class. And if there's two different ways to make it, where one of them does validation and the other one doesn't, now you have a way to make invalid objects. And we're really trying to prevent that from happening in the first place with this strategy. Yeah, but that's a great question. Thank you for asking. Okay, so I'll update this diagram and save it and post it up on the course lecture notes for today. But the state that we're in is effectively this right now. We have got a class that's called create Pokemon display. This class has the responsibility of getting input. It has the responsibility of taking that input and passing it to this class here. The class that we have on the right is something that is embedded inside the Pokemon class. We have to make this an inner class because we've marked the constructor private. I will put an alternate example of this up where the Pokemon Builder class can be in a separate file where we don't mark the constructor private, but we make it effectively private. But I will just put that up after class. I'm going to keep with this strategy here that we're looking at right now. The Pokemon Builder class is embedded within this Pokemon class, so it has the ability to see that private constructor. And the Pokemon Builder class is the thing that now has the responsibility of validating all of the inputs. So taking each input with one method and validating that one input with one method. There was a question asked on the forum about the strategy that we had before where we were checking to see if nickname is not equal to null or if it is equal to null here and kind of comparing the differences between preconditions of methods and checking for validity of methods. And I think that the person was right to kind of call this up and ask about why are we doing this null check here? Shouldn't we be doing this? So preconditions.check.null. and I agree with that person. Effectively, we want to make sure that we're not getting null. We still want to prevent that from happening in the first place. But my parents cannot type null in on the keyboard. They would never be able to enter null. And so this is effectively a programming error for somebody to be able to pass null to this in the first place. So having this be a precondition here makes sense. Once we know that it's not null, this, at least in the case of this nickname, we have the responsibility of checking to see, is this thing empty or not? This is what we define as valid for a nickname. And if it doesn't meet the criteria for what a valid nickname is, then we're going to raise an exception. So as soon as possible, and I'm going to scroll down here a little bit, I put these each in methods here. This is get nickname input. Effectively, as soon as possible, print out, enter a nickname, get the next line from my scanner, ask the builder to validate it. Immediately after getting that input, the validator will do the validation, and it will either throw an exception, you have entered something invalid, you need to fix this, or it will say, oh, okay, it won't actually do anything. It will just keep the value in its own internal state, and then you can proceed with building this thing up. If there's an error right now, we're just printing out a pretty terrible error message to the screen, and then making sure that we're going to continue to prompt and ask for that thing repeatedly and repeatedly and repeatedly. Are there any questions about the state that we're in right now? Yeah. Of course, yes. On up here. So I was wrong when I said the word number format exception. It is input mismatch exception. So I've been typing this stuff in and checking it on my own time. And forgive me for constantly saying number format exception. It's input mismatch exception that gets thrown when you type in the number 5 as a word 5 there. Yeah. Yeah. You all doing? You're all looking like you need a term break right now. Yeah. How are you all doing? What other classes are you taking right now? 2400 I hear immediately before class. Yes. What other classes are you taking right now? 2140. Okay. How's that going? No, shaking heads. Okay. 2080. Okay. Math 2080 or Comp 2080? Comp 2080 is next term. Math 2080? Yeah, okay. Okay. I never took that course. Okay. I'm sorry to hear about that. I hope that what we're doing here is going okay in general. I hope that what we're doing here is going okay in general. And I'd love to help you with your Comp 2400 stuff, but it's not going to happen. Okay. So where we left off last time, the very last thing I wanted to be able to get as input for my Pokemon type was the type of Pokemon. And I want you to be able to basically say that, what kind of Pokemon is this? Pokemon type was an enumeration, and I'm going to pop over here to that enum type. And so I know there's lots more in the world of Pokemon, but for us, for this class, for right now, these are the ones that we care about. So normal, water, fire, grass, and electric. These are the ones that we care about in this particular class. With max HP, we were able to ask Scanner to give us an integer, and it was Scanner's responsibility effectively to do some kind of validation for us and then tell us, no, the thing that was entered was not an integer. And that communicated to us as devs that we need to write a loop on this to make sure that we actually get something valid as input. But Scanner doesn't really have a method here for arbitrary enumerations. And that's totally fair because there's no way that Scanner could deal with an arbitrary number of different enumerations. And so our strategy for Pokemon type is going to be a little bit different. I'm going to say that you could put this idea into the builder, but I want to put it as close to the domain model class or type as I possibly can here. And so in this case, while Pokemon type is something that I do pass into the builder that I'm working with, creating an instance of Pokemon type is the responsibility of this class, the enumeration itself. Creating an instance of this is also kind of weird because enums are just like you say Pokemon type dot whatever, and you get that specific instance of this thing. What I really want to be able to accomplish here is I want to be able to make an instance of Pokemon type using a string as an input. I want to be able to pass a string to this, and I want to be able to get back one of these enum types themselves. And so to accomplish that, I'm going to write a method here that's called fromString. This is going to be a static method on this enum class because I want to be able to call it on the class itself. I'm not calling this on specific instances of this thing. There is a method that's called value of that's going to look a lot like what we're doing here. This is defined on the enum type itself, but ultimately I want to be able to throw custom exceptions from this thing, and so that justifies writing my own method for this purpose. So I'm going to write this method, public static Pokemon type, and I'm going to call it fromString. And it's going to take as input the value that I'm going to be converting from. I'm going to move this over just to the side here. I'm going to say that just like the other things in my builder pattern, in my builder class, this is going to be able to throws exception. This is going to be able to throws exception. If there's something that is passed to me that is not valid, then I want to still be able to raise an exception so that as soon as possible, I can say the thing that you've entered is not a valid thing here. This, for me, is going to be a straight switch statement, but I want to check that the value that was passed to me is still not null. So preconditions.check not null, value the value passed to this enum should not be null. And then I'm going to do a switch on this. So I'm going to say switch value. And I'm going to use a slightly newer version of switch that's available in Java. I'm actually going to say return switch. And what I'm going to do here is I'm going to say case normal and then arrow, so dash greater than symbol, and then I'm going to say normal here. Then I'm going to keep iterating over all of these possible values. And then I want to have a default. So if it doesn't match any of the things that have been passed to me, I'm going to say throw new exception. So in the very default case, I don't want to return anything. I just want to raise an exception. Yeah. So this is a feature of Java, at least I think 17 is where this was introduced. This is a switch on strings that does comparisons of strings using dot. I think it does dot equals underneath, but it just means you don't have to type dot equals a bunch of times. Yeah. You could do this with a giant conditional statement if you wanted, but this is a lot more concise. Yeah, yeah, yeah. In this case, I believe it's using dot equals. So if you wanted to be able to type in things that were mixed case, you would want to use dot to lowercase or to uppercase before you do the comparison on this thing. Yeah. I'm going to make the argument that at least for now, we should be typing in the thing that is the uppercase representation of that. But that's going to be part of what we get to a little bit later when we're printing out these messages. Okay. So I've got this from string method now. It throws an exception, and this is effectively what I'm going to use when I get input from my user to get that value and pass it into this thing. So I no longer have to do this anymore. What I'm going to say here is that I'm going to change the name of this to Pokemon type input. I'm going to create an instance of Pokemon type. And I'm going to say that Pokemon type, Alt-Enter, is equal to Pokemon type dot from string, and I'm going to pass it Pokemon type input. And then I'm going to use my builder class, and I'm going to say that the type should be equal to Pokemon type here, not with question marks around it. I'm going to take a look at the builder class again here on Pokemon type. Once we get to having this method setting this property, we no longer really have to check for validity of this object because we've effectively done that by transforming it into an instance of one of these enum types. The only invalid thing that we can provide to this is null at this point. And so having that precondition for null is still there, but then we can otherwise just accept that the value that's being provided to us is valid. The compiler will prevent us from doing this in the first place. All right, we all okay with this? Yeah. How we could possibly pass null to one of these Pokemon builder. The error here is if I were to say something like this. It would be me having to type this in the first place. My parents, the people that are going to be typing in Bulby for, they're typing in the word grass here. They can't type a null value in here. But if I did default of null, and I'm going to run this again, 5, I'm going to type in something that's not in that list, not in the list. Then I can kind of type null in here. But it's me having done the code to have caused null to be passed to this in the first place, as opposed to my parents doing something here. By raising the exception here, I'm effectively ensuring that I can't. But as a person that's writing code here, I still want to make sure that I haven't done that. And putting these preconditions into these methods is forcing me to make sure that I haven't done that in the first place. Yeah. It throws an exception. So check not null will throw a null pointer exception. Check state will throw an invalid state exception. So that's a good question. That's a fair question. And I think that's maybe related to the question that you were asking here. How could we possibly pass null to this thing? The answer is I'm doing the best I can to make sure that I don't pass null to this, but I got to remember that I'm not the only person that's going to be using this code. If I give this to you, you could write code that uses these domain model types, and you could pass null to these domain model types. Not on purpose, but you could do it unintentionally. And what I'm trying to do with a lot of the stuff that we're working on right now is effectively force you into making sure that you can't pass null into those things. I still want to guarantee that you haven't, and the way that I'm doing that guarantee is by using these preconditions and ensuring that as we're developing this code or as you're working with this code, you're going to find those exceptions and then fix them yourself in the code that you've written. Yeah.
If value was null and a precondition, a check on null was not there, would it just use the default return switch, or would there be an error caused before it even gets to get there?
That's a great question, and I don't know the answer to it. I mean, I'm willing to humor you and try. I don't know what would happen if I do this. It's probably a null pointer exception. It doesn't matter what I type in here. It's going to have null being passed into it, so something. We get an exception that's being raised, so I'm going to put a breakpoint here. And what we're getting as the exception is it's a null pointer exception. It's using hash code internally. Okay, so there's our answer. It uses hash code internally to compare with the switch. Again, that's pretty specific and pedantic. And to be clear, I'd never ask you that question in any way, shape, or form to try figure anything out like that. All right. Okay. So at this point, I am pretty much satisfied with our validation. The very last part of this is I need to be able to actually construct an instance of this thing. I actually have to be able to construct an instance of this thing. And so that's where this last method in this strategy shows up with this build method. This is the one that I'm going to call the constructor in for this type, and it's going to return an instance of this class. So I'm going to move this all over to the side here, and I'm going to take a look at just this. And what I really want to do here now is I want to be able to say return new Pokemon, and I want to pass to this all of the things that I have collected over time as part of this builder strategy. So I'm going to pass a nickname to this. I'm going to pass the type to this. Pokemon type. What did I call this? It was type, yeah. The initial health, max HP, and then the initial moves. I'm just going to say that I want this to be a list of everybody's going to get a new tackle here. So I would proceed to add parts of the builder here, tackle. I would be able to proceed to add initial stuff, more stuff for the builder here to make sure that we can accept these different moves that we want to accept as input for this. But for now, I just want to say that everybody's going to get a tackle when they're constructed. I'm going to leave this as a question for you, and I'm leaving this as a comment in the code that I'm going to push up after class. Should this build throw an exception? We have exceptions now on every possible value. We have exceptions on every possible value that we are able to provide to this thing in this builder class. And now we've captured all these values. And my question for you, and I don't want you to answer now, but my question for you as the reader right now is, should this throw an exception too? And what are the circumstances under which we might want to throw an exception in this method? I'll take a look at this next week. But I want to leave you with that question to be able to think about. Yeah.
So that was just to protect against the validation, not that
That doesn't make us only have one Pokemon. It makes it so that we cannot call the constructor outside of this class. So that means that to be able to create an instance of this, we're forcing other dev folks and ourselves to use this strategy, this class, to be able to create that instance. But we haven't made a singleton as far as like design patterns go. We haven't done that. Okay. All right. Okay. So I'm going to switch back over to my slides here for a second. And effectively what we've done here is we've done this. We've added this type input by implementing this from string method. The problem that we have right now is that throwing new exception is kind of a terrible way to send information between layers to say what has actually gone wrong. What we've accomplished by throwing this exception is to say that something went wrong. Yeah, something went wrong, but we haven't really effectively communicated from the logic layer, from our validation class, from our domain model object, what actually went wrong. This is fine for what we've done right now, But one of the things that we are able to do with the strategy that we have built up here, I'm going to pop back here very quickly to this code. One of the things that we've effectively been able to do by creating this pattern, using the strategy that I've described to you, is that we are able to call our builder methods like this. So I can create an instance of that type. This is what that builder variable is there. And then I can say .nickname, and then .type, and then .maxHP. Returning this in every one of those methods accomplishes this ability for us to do this method chaining. And I'm going to keep calling these methods on exactly the same instance every time. And every time I do this next method chain, I'm just going to be able to provide new values for this thing. If I have try and catch exception, I don't know which one of these caused that error. In the way that we were doing it with like get one input and validate, we know which one caused that error because we only had one thing. But this is an alternative way to use our builder, and this would be a more appropriate way to use our builder when we have, for example, a GUI class that has a bunch of text fields on it, rather than doing it one thing at a time. So what I really want to be able to accomplish here is I want to be able to communicate to different layers what's happened. And this was an idea that came up last time we met. Why not just put a string inside the message field of this exception and use that to communicate to the other layer that something has gone wrong? And that's okay. That does do a better job of communicating what's gone wrong to the other layer, but this violates that single responsibility principle. It violates the single responsibility principle in the form of only the UI layer should have this responsibility of producing messages that are going to appear as outputs. It should not be put onto the responsibility of our domain model objects. None of the domain model objects that I'm building up here should have any responsibility for printing anything, and it shouldn't have any responsibility for constructing strings that are going to be printed for the person that I'm working with. So what I want to do is I want to communicate between these layers of responsibility by having some better exceptions. Remember, the goals that we had for validating input was that we wanted to be able to communicate what's wrong as soon as possible. We're able now to communicate as soon as possible. What we want to focus on right now is to communicate what is wrong, what has actually happened that we have determined is invalid. Better exceptions are able to communicate better what is wrong to the other layer of responsibility that we're working with here. Java itself, and you've experienced a lot of these different exceptions, Java has a ton of different exception types that you can have. Some of them are useful to us, but in the great majority of the types of exceptions that we've got, they're not really super useful. This is a link to Java's exception type, and you can see that there are millions and millions of different kinds of exceptions that the JDK defines, but class not loaded exception and data format exception, while they might be meaningful in some contexts, are not necessarily going to be meaningful in the context of, I'm trying to set the nickname on a Pokemon right now and you provided an invalid value for that thing. So what I want to do here is I want to be able to make our own custom exceptions. Exceptions in Java are just classes. There's nothing really special about them. They are just classes. There's one minor thing that's special about them, and the minor thing that's special about them is that they extend another class. The one minor thing that's different about classes that are exceptions are that they extend the class called exception that's in the JDK. And in our course, this is the one place where we're going to use the extends keyword. We're not going to use this in any other context in Comp 2450 other than this one. This is the only place where we'll use this extends keyword. In short, the extends keyword effectively says that this is a relationship. The other relationships that we've been working on in class are has a relationship, so composition. I believe in Comp 2400 right now, you are talking a little bit about classes and inheritance. So you're thinking about that in other classes. This is what we're going to be doing in this course right now. I want to make at least one exception. I don't think I'm going to go through each of these in class, but I'm going to go through one of them. And what I want to do with, I think I'll focus on the invalid nickname exception here. So I'm going to pop back over to my code. I'm going to share this with you again after class. I'm going to close all of these for now, and I'm going to open up my File Explorer. And the reason I'm opening my File Explorer is that I actually want to add a new package to my domain model classes. I'm going to add a new package to my domain model classes, and this is going to be called exceptions. I want these to be in my domain model package because it's my domain model classes that will be throwing these exceptions. I could put it in its own separate package, but I want to keep them packed together. I want them to be physically close to each other so that it's clear that there's a relationship between those things. I'm going to make a new class here, and this class is going to be called invalid Pokemon nickname exception. A common idiom for exceptions is that the last word in the class name is exception. This is a very common idiom. When I'm writing exceptions, I want to try to make sure that the name of this exception communicates to you folks, developers, what the problem is. I'm not communicating this exception directly to my parents, but you should know what this means by looking at the class name for this thing. So this is an invalid Pokemon nickname exception. Sure, I'll add this to my version control. And I want this to extends exception. I want this explicitly to extends exception. We're done. We're actually done. We've made our own custom exception. This is a class, so like we could do a bunch of other stuff. Like I could have things like private final string invalid nickname. And I can't have this have a constructor, public invalid Pokemon name exception, and I want to take an invalid name. And I can have this have values because it is just a class. This is something that is totally valid to do, but just having the class extends exception is good enough. We don't have to have much more beyond this. If there's stuff I want to communicate to that other layer as part of this exception, then I will add these things. If I don't care, then I'm just going to leave it empty and just have it be the class that it is. Now that I've got this exception, I want to take this and I want to throw it in the place where it's appropriate to throw it. So I'm going to go here and I'm going to look at Pokemon again, and I'm going to look specifically in this builder class that we've added here. And what I want to explicitly say here is now no longer that it throws exception, but I want it to throw a specific kind of exception. And so I'm going to change this to say invalid Pokemon nickname exception. And I'm going to change throw new exception to invalid Pokemon nickname exception. And I can pass to this the nickname that I have been passed myself. I am not doing system.out.println in my class here. I am not doing system.error.println in my domain model class. My domain model class does not have the responsibility to produce output that represents errors. It does not have the responsibility to produce output at all. It has the responsibility to communicate that something has gone wrong to the layer that is responsible for producing that output. And so I'm going to finally pop back over here to the Pokemon create Pokemon display class. And I'm going to go back up to go down to the get nickname input. And while I can continue to catch exception here, in cases where I can throw multiple different kinds of exceptions, I want to be explicit about the thing that I am catching here. I don't want to catch null pointer exception. I don't want to catch any other kinds of exceptions when I'm printing out, you must enter a valid thing. I want to explicitly capture invalid Pokemon nickname exception. So I'm no longer catching exception here. I'm catching this specific kind of exception. Yeah. If I were, that's a good point. If I were now to pass null to this, I would see null pointer exception. And again, I'm going to make the argument that I know that I've done something wrong. But my mom and dad shouldn't see null pointer exception because I will have worked that out before I give it to them to try out. Yeah.
I'm wondering about this preventing null stuff. So what if our implementation of a class actually prevents one of its fields being null because it's part of the logic? Is it like a red flag that our implementation is bad and we should replace it with something else, like an optional, for example? Or like it is allowable to like make that field null if the implementation requires it, so if the logic requires it?
So if there's an appropriate value in a domain model object, and I believe there are cases where that is the case, the JDK does have optional types, and that would be an okay alternative to this. What I would say is that your class invariants should basically be making sure themselves that the things that you're doing with that null type make sense. So the specific conditions under which it's a class invariant. And then I generally argue that you should try not to return null from any of the methods that you have in that class. So if there's a circumstance where you might otherwise be returning null, raise an exception because it's maybe an invalid state for that thing to be in. Yeah. All right. Okay. I'm going to pop back to my slides one last time here. Yeah. This is maybe not an exceptionally good error message for my parents to see. I'm pleased with myself that I've made this red, but that's about as much as I can say about how good the error message is that we've got so far in our structure. What we've got right now is our domain model objects are able to communicate to the UI layer that something has gone wrong. They're able to communicate to the UI layer that something very specific has gone wrong, and they're able to communicate that as soon as possible. They're able to send that information back to the UI layer as soon as possible. And now I want to take these exceptions and I want to translate that into something that is usable by my parents, usable by other humans, usable by people that are using my software. We want to be able to communicate what's wrong. We've accomplished that. We want to be able to communicate as soon as possible. And now we want to be able to communicate how to fix it. Error messages that we actually print out should look like this. They should very clearly state the problem. And so what I mean by that is they should strive to say what was incorrect or invalid about the input that as much as they can. Null is not a case that I need to report to my parents here. The message that I'm providing here does have to have some understanding or knowledge of what's being validated internally. It kind of has to be able to know that you can't pass an empty string for a nickname. It has to know that to be able to print that out. But I pretty clearly want to state what was incorrect or invalid about the input provided. And the other thing error messages should do when I'm printing them out is that they should explain how to fix the problem. And so what that means is that they should either provide an message that says what the information is that's necessary to provide correct or valid input, and additionally they show what that looks like. So when I'm asking for a number and I'm expecting it to be a positive number, I should print out, it should look like this, 5. This is a good value for what I'm trying to accomplish. When I'm trying to get values for an enumeration, it should print out, I would expect you to type in one of these things. These are the values that I'm looking for you to type in here. So very quickly in the last moment of classes here, what I want to accomplish is I want to print out at least one appropriate error message for one of the cases that we're looking at here. And so I'm going to pop back to my code one last time here. And we're looking at this invalid Pokemon nickname exception right now. And so I want to print out an appropriate message for this. So I want to be able to print out an error to the user. I want to be able to tell them what's wrong. And I want to be able to tell them how to fix it. And I want to be able to provide an example of what that looks like. So I might have red here still, but the message that I really want to type in here is nicknames cannot be empty. Quick thumbs up, quick thumbs down, asking about your parents and not my parents. You don't. Good. No, our parents don't generally know what empty is. Names must have at least one character. Okay. Do my parents know what the word character means in this context? Do you have a question, or are you saying yes? That's a great question. Your question is, do we need to think about local? This is where we would do that, yes. But in the context of this course, we're not going to do that. Yeah. But this is the right place for that. This is exactly where we would put that information, yes. Nicknames must have at least one character. Nicknames must have at least one letter. Do my parents know what that means? Yes. I think everybody's parents know what that means. Yeah. Yes. We assume that our parents can use a computer. They're typing stuff into this right now, but they don't know what a string is. They don't know what the technical details of our implementation are. Nicknames must have at least one letter. E.g.,